Welcome everyone to Plug and Blocks tutorials for electrical systems. In this series of videos you are supposed to learn more about the DC systems and AC systems, and why Mr. Edison had to stick with the DC system and why Tesla's vision for the AC system became true. Why the whole infrastructure is an AC now, and if you had the opportunity one more time to build this infrastructure from the scratch, would you have built it as a DC system or an AC system? And what are the struggles that faced the DC system in the past? All of this you are supposed to learn in this series of videos, and hopefully by the end of this series of video you will have a clear vision of if you have the chance to build this infrastructure, would you have built it as a DC or an AC system? So let's get started. We're gonna start with the DC systems. A simple DC system should has DC current, DC voltage, and resistance. Those three main components that you need to learn to understand a very simple DC system. So let's draw a very simple circuit for a starter. So this is a DC voltage source. This is simple for DC voltage source and is connected via wires to a resistance and back to the voltage source. This is DC voltage source and this is the resistance. Basically, the circuit is a connection between the source and the load or whatever you have. It's a connection between electrical components. This is your wire. So let's start with my favorite one, the DC voltage source. DC voltage source, you can imagine it as a pushing force, and you can imagine the resistance as the villain in the story. That is the opposition force to the DC voltage source. But what is this really pushing and what is this really oppose? They are pushing and opposing charges. You can draw it here as a positive charge, as you can see here. So the DC voltage source is trying to push those charges and the resistance is trying to oppose them. This flow of a charge is the current, and it has a simple I, and it's equal to d by dt of the charge, q. d by dt is the rate of a change of a charge. So whenever you have a flow of a charge or rate of a change of a charge, you have a current. And in order to have a current, you need some pushing force, which is the DC voltage source. Basically, they call it electromotive force. But we have the resistance, which is trying to oppose this flow. So basically, this is the circuit. But let's take a closer look on this circuit. Let's go to the atomic level and see what actually happened. But before we do that, I need you to recall with me the atom. If you recall, the atom has the nucleus, which has the protons, which are positively charged. You have the neutrons, which are electrically neutral. You have the orbits around the nucleus, and those orbits has electrons revolving around it. Let's say just for the fun out of it, we have two electrons here, which is usually the case, and you have one electron at the outer shell. In an electrically neutral atom, the number of protons is equal to the number of electrons. The electrons are negatively charged, protons are positively charged. And I need also you to recall that whenever you have similar charges, they repel each other. So if you have an electron and electron, and they are close to each other, there will be a repulsion force between them. And whenever you have unlike charged or opposite charged, they attract each other. So let's now jump back to the circuit that we had and jump to the atomic level and see how it will look like. As you see here, this is the DC voltage source I told you about, and those are the atoms of the wire. So this is the atomic level of the wire, and this is the resistance. So as you can see here, it shows copper to be my atom. Why? Because most of the wires are copper or aluminum, and they basically choose it for a good reason, because they have low resistivity, and we will talk about this later, but let's keep it simple for now. So you have those copper atoms. The wire have a multiple copper atoms. You can say millions, but just for simplicity, let's take only 3 now. And you have this DC voltage source. This is the positive of the DC voltage source and the negative of the DC voltage source. So remember, I just told you, when you have opposite charge, they attract each other. This electron in the outer shell is bounded to the nucleus through an attraction force. So this electron here is bounded to the nucleus through an attraction force. So now, if this positively charged blade has a higher attraction force than the attraction force between the electron and the nucleus, this electron will jump from here to there. And usually the electron in the outer shell has a very small attraction force between it and the nucleus. So if this happens, the electron will leave behind something called a hole. This hole is positively charged because now you have the number of protons is greater than the number of electrons in this atom. So this atom will have now an overall charge positively charged. So you have here positively charged, which is the hole. Now the electron, this electron will be attracted to here, and then one more time attracted to here, leaving behind positive charge. And then this electron will be attracted to here, and then back to the source. So what do you see now in front of you? If you take a closer look, you can see that the positive charge are moving this way and the electrons are moving in the other way, right? So, and both of them are happening at the same time. So it happened that they chose that the direction of current will be the direction of the positive charge. And remember, we said that the DC voltage source is a pushing force, right? But what you can see here is like it's attracting the electron. But if you look to the positive charge, this positive plate is pushing away the similar charge, right? As we said before, similar charge repel each other. So this is acting as a pushing force to those positive charge to move in this direction. Okay? But what the resistance is actually doing now? To imagine the resistance, let's draw the whole circuit in a different structure. Like, let's say that you have a pipe. This pipe represents the wire, and the current is represented by a water flowing through this pipe. Okay, you have a cylinder here, and this cylinder you can push it in this way. So this cylinder with the pushing represents the DC voltage source, the current flowing is the charge, this pipe represents the wire. So where's the resistance now? You can say that the resistance is this pipe being tied up, being tightening and tightening. So what happened now? What do you see? Once you have this tightening, what will happen to the water flowing through it? The water flowing through it will become less and less, right? As more as this tightening increases. This is actually what the resistance is doing. As the resistance increases, the charges decrease in the circuit, which means that when the resistance increases, the current decreases. And this is actually, we will learn more in Ohm's law, which we'll talk about in the next lecture. But for now, this is how you can imagine the resistance. So there's a funny picture, I want to show it to you. As you can see here, this is the resistance, the voltage, and the current. The current is the flow of a charge that is trying to flow, the voltage is the one that will try to support it, and the resistance is the one who will try to oppose both of them. So this is how you can imagine the three of them. So in this lecture now, we have covered the DC current, which we said is the flow of a charge, this one, and we covered the DC voltage source, which we said is the pushing force, and the resistance, which is the opposition. In the next lecture, we'll be covering the conductors and the insulators, and we'll take a closer look on the resistance, and we will do our first experiment. Hopefully you enjoyed this one. See you in the next one. Thank you.